In a previous lesson, we learned about reference angles. You may wish to pause the video at this point in order to refamiliarize yourself with this concept by studying this slide before moving on. In this example, we're to find the reference angle theta prime when theta equals 300 degrees. If we look at the diagram below, we can see that 300 degrees lies in quadrant 4. Therefore, to find the reference angle theta prime, we need to subtract 300 degrees from 360 degrees. The result, 60 degrees, is our angle theta prime. Theta prime is represented here on the diagram. In the next problem, we're to find the reference angle theta prime when theta equals 2.3. Recall that in working with radians, we can either work with them in fractions, for example pi over 2, or decimal form. The decimal form is determined when we substitute approximately 3.14 into pi. So for example, on the positive y-axis, we know that that equals pi over 2 radians. If we substitute 3.14 in for pi and divide by 2, that's equal to approximately 1.57. We also know that the negative x-axis between quadrants 2 and 3 is pi radians, and that is equal to 3.14 approximately in decimal form. Since we're working with angle theta equals 2.3, we know that that's going to lie in quadrant 2 between the radians 1.57 and 3.14. Here's our angle in the diagram. Now we need to find the reference angle. To do that, we're going to subtract from pi 2.3. The result is approximately 0.84. This is our reference angle in quadrant 2. In this example, we're to find reference angle theta prime when theta equals a negative 135 degrees. So we have a negative angle, or an angle that goes in clockwise position, as shown in the diagram. We need to find a coterminal angle so that we can work with a positive angle between 0 and 360 degrees. To do that, we're going to add one revolution, or 360 degrees. So if we add 360 degrees to negative 135 degrees, we'll find the coterminal angle 225 degrees. This is represented in the diagram, and it lies in quadrant 3. To find the reference angle theta prime, we need to subtract from 225 degrees 180 degrees. The result is our reference angle theta prime, which equals 45 degrees. Now pause the video and try this problem on your own. In this problem, we're to find the reference angle theta prime when theta equals 7 pi over 4. It might help to skip straight to option C, sketch and label a diagram of theta and theta prime in order to help answer questions A and B. So let's sketch a little diagram here. Now 7 pi over 4 is going to lie in quadrant 4, approximately here. So angle theta is going to go in a counterclockwise direction, and it will end here. That's angle theta. So theta prime, our reference angle then, is going to be in the 4th quadrant, and it's going to be here on the diagram. So we know that we're in quadrant 4. So in order to determine our reference angle, we need to subtract 7 pi over 4 from 2 pi. So 2 pi minus 7 pi over 4. We need to use a common denominator of 4. So 8 pi over 4 is equal to 2 pi minus 7 pi over 4. The answer is pi over 4. So our reference angle, theta prime, is pi over 4. In our diagram, theta prime down here equals pi over 4. Now go ahead and try this problem. Please pause the video and restart it when you're finished. We'll again draw a diagram first to help us visualize this problem. 5 pi over 6 will lie in quadrant 2 approximately here. So theta equals 5 pi over 6 would be representative of this angle here. Theta equals 5 pi over 6. So our reference angle then will be here, and it lies in quadrant 2. And in order to determine that mathematically, we need to subtract 5 pi over 6 from pi. So again, we're located in quadrant 2, and to find our reference angle, we're going to take pi and subtract 5 pi over 6. We need a common denominator, 6. So 6 pi over 6 is equal to pi, minus 5 pi over 6 equals pi over 6. So our reference angle is pi over 6. In the diagram below, pi over 6 is our reference angle in quadrant 2.